All right. We're going to talk about a bunch of gas laws that pertain to things like the pressure, volume, moles of gas, and temperature of a sample. They're all interrelated. And the first one that we're going to talk about is Boyle's Law. You should know the name of the law, the person that it's associated with, and then what variables are involved and how they are related to each other. Okay, so Robert Boyle is the person that studied the relationship between volume and pressure of a gas in the mid-1600s. He found that pressure and volume are directly related. You're going to see me abbreviate pressure as P and volume as V, okay? The two variables that are not being mentioned here are being held constant. So keep that in mind anytime you read a problem. If they don't mention it, it's not relevant because it's being held constant, or they may tell you it's being held constant. So N, which is moles of gas, and T, which is temperature in Kelvin. These are the two variables that are being held constant. And what this relationship tells us is, let's say you've got a volume of let's say this is 2 liters here of gas. And let's say we have it, and this is a liter. So as you go from here to here, you divided the volume by 2. So this would be your V1. This is your initial volume. This would be your V2. Okay? That means that the pressure, and I'm sorry, this is, I don't know what I was thinking. This is inversely related. I don't know why I said directly. So that means since the volume is going down by 1/2, that means the pressure should go up by 2. So this pressure, let's say this initial pressure is 1 atmosphere. That means that this final pressure should be 2 atmospheres because going from here to here, it should double. Okay, so that's the relationship when things are inversely related. If I had tripled the volume, that means I would have decreased the pressure by 1/3. You get the idea, okay? Okay. Hi. Thank you. You bet. So much. Let's take a look at the graph. This is going to be pretty common sense here. If you were to plot 2 variables that were inversely related, the graph will appear the same every time. The graph will look something like this, okay? What they like to do here with Boyle's Law is they'd like to invert one of the variables, and then what that does is it changes your line and it makes it appear direct, but it's not because you inverted one of the variables, okay? So just keep that in mind. Let's go to the next page. P1 times V1 equals P2 times V2 is the relationship for Boyle's Law, okay? I will be giving you an equation on a test or a quiz that has all of the variables in it. Some of these I haven't explained yet, but I'm just showing you now so you understand that the way that you can get this is if a problem says that variables are constant or the variables aren't mentioned, you can cancel them out of the equation and it will give you what you need to solve the problem, okay? All right, now, if you're doing a lab and you are collecting some pressure and volume data in a spreadsheet, if you take the pressure value and you multiply it by the volume value all the way down that data table, you will end up getting some constant number. They refer to that constant number as K. So that means pressure times volume equals a constant K for Boyle's Law. Okay? All right, let's take a look at a practice problem. All right, let's take a look at number 2. Most of the practice problems in this section have to deal with this kid Zippy and his misadventures, okay? So here it says, Zippy feels like celebrating the Seahawks beating the Broncos in an away game, so he takes a red balloon up to the 24th floor of his hotel room. The balloon's volume was 5 liters at a pressure of 101 kilopascals in Seattle. So this is your V1, and this is your P1, because this is where you're starting, okay? The balloon's volume, once it gets to the 24th floor of the hotel room, is now 5.6 liters. The temperature hasn't changed, so we don't have to worry about it. They want to know what the pressure is in that balloon in Zippy's hotel room. So this 5 liters would be my V2. P2 is what I'm solving for. So P1 times V1 equals P2 times V2. So you're going to take 101 times 5 equals P2 times 5.6. Just make sure that your units match when you put everything in here. Your volumes don't have to be in liters. They can be in any other unit as long as they match. Bless you. Divide both sides by 5.6. So this cancels. You're going to round your answer off to 2 significant figures. I've got 90 kilopascals. Since I want 2 sig figs, you're going to have to put the decimal point on the end to make that trailing zero count. Okay? That's Boyle's law. All right? All right, let's go to the next law. Let's talk about Charles's law. Okay. Jacques Charles studied the relationship between volume and temperature of a gas. He found that it is a direct relationship, but be careful with the temperature. The temperature has to be in Kelvin. In fact, in this entire chapter, the temperature has to be in Kelvin if you're using it in a math problem. So keep in mind, degrees Celsius plus 273 equals Kelvin. Okay, so we'll be using that. Let's take a look at the next page. And let's look at this figure. Okay, so since I'm looking at the relationship between temperature and volume, here in this glass tube, they've got some air trapped. Okay, and obviously the volume is changing. Let's assume that the volume here is like, I don't know, 5 milliliters. And let's assume over here the volume becomes 10 milliliters. I'm just making it up. So V1 to V2, as you go from here to here, the volume doubles. Okay, so that means that the temperature would have to double as well, right? Because they're directly related. So if T1 was, let's say, I don't know, let's say it's like 5 Kelvin. That means my T2 would have to be 10 Kelvin, because going from here to here, that would have to double to support the fact that this is a direct relationship. Do you follow me? Okay. All right. So the 2 variables that they are not mentioning here are pressure and moles of gas. So that means P and N are being held constant. You know that if you plot 2 variables that are directly related, it will be a straight line. You need to be careful here because you absolutely have to plot the temperature in Kelvin, because if you plot it in degrees Celsius, it will not go through the origin. So down here, they're showing you that if you plot degrees Celsius versus Kelvin, Kelvin will go through the origin, whereas the degrees Celsius will not. Degrees Celsius takes you all the way back to an x-intercept of negative 273. Well, isn't that what we add to get us to 0 Kelvin? Okay. And then in terms of collecting data for something like this, if you're doing a lab where you collect volume and temperature data in Kelvin, if you take that volume value and you divide it by a temperature value, you will get some constant number all the way down for that set of data. that constant is given a variable of K. So that means for Charles's law, volume divided by temperature will equal K. And then if you take a look at the next page, they give you the equation for Charles's law. So this equation is V1 over T1 equals V2 over T2. Even the best math students mess this up every year. So I highly suggest you cross multiply before you do anything. Okay? Let's take a look at a practice problem. Okay, when he leaves for breakfast the next day, Zippy puts his cheese curls on a windowsill in the sun. Over a period of time, the temperature of the cheese curls increases from 19 to 34.5 degrees C. So this means your T1 is here, your T2 is here. If the volume of the bag is 121.9 milliliters when they're put on the windowsill, what will the volume be after warming? So this is your V1. And then we're solving for V2. You need to make sure that your temperatures are in Kelvin. So that means you have to add 273 to each one. Okay, so you're going to end up with, let's see, T2 is going to be 307.5. And then T1 is going to be 292 Kelvin. So we've got V1 over T1 equals V2 over T2. Cross multiply. And then 121.9 times 307.5 equals V2 times 292. Divide both sides by 292. This cancels. You're going to end up with 128 mils. I essentially have two more laws, well, three more laws to talk about. One of them just brings them all together. Yeah.
Can volume be any unit as long as it's
constant? Yeah. If they're both centimeters cubed, fine. They're both milliliters, fine. Okay. Yeah.
If you had to convert it, which one would you convert to? So like if V1 was milliliters and V2
doesn't matter. Yeah. The only thing that would matter is if they told you that they wanted you to solve for V2 in liters, but one of them was in milliliters, then you'd obviously convert it to liters. Okay, we good? All right, let's move on to Gay-Lussac's law.